Hello everyone, this is Abhigyan Dev, and today I'll be discussing our project Diabetes Prediction. My teammate in this project is Anirban Banerjee. He'll be joining us later. So the aim of our project is to graphically visualize the dataset collected from Kaggle website and to apply concepts like data exploration, data cleansing, feature selection, model selection, etc., and apply them in a practical way. So about this data set, which we took from Kaggle, this was collected and made available by National Institute of Diabetes and Digestive and Kidney Diseases as part of the PIMA Indies Diabetes Database. Several constraints were placed on these selections of these instances from a larger database. In this project, in order to develop the model, we'll be using Python and import some of its popular data science related packages such as pandas and CSV files. We will also be using matplotlib for visualization purposes. We will also import some algorithms like logical regression, Gaussian NB from sklearn. These algorithms will further help us in a classification model. Now we will be pre-processing our data. We will be first checking for any null or invalid value in any column. For example, BMI of a person can't be zero. So we will be modifying the dataset by removing the rows containing these invalid values. After that, we will be training and testing our dataset. So to do that, we will divide the dataset into independent and dependent axes, and then we will fit different classification models such as logical regression, Gaussian NB, etc. to the dataset. Then we will check the individual accuracy of each of those algorithms. We will plot those individual accuracy scores in the form of a bar graph. After that, we will be applying cross-validation. So what is cross-validation? In cross-validation, we basically choose a different portion of the data for training and testing and re-evaluate the model performance to get more accurate results. So after cross-validation, we will plot a new bar graph using that upgraded accuracy values. And after this, we conclude that the most accurate models are logistic regression and Gaussian NP. So after that, we will be applying logical regression to the training dataset, and we will make a note of the accuracy, mean, standard deviation, etc. And we'll be plotting a graphical representation of the predicted data and the original data using a scatter graph to observe the similarity between them. So after that, we'll be similarly applying Gaussian NB to the original dataset. Uh, Similarly, we'll be making a note of accuracy, mean, standard deviation, etc. So now my teammate Anirban will explain these topics in further detail.
So, hi, I am Anirban. I will be discussing the code which I have uploaded in my GitHub link. So, we can see that this is the data set diabetes2.csv. As my friend told, it is collected from Kaggle. I will be explaining the Python code now. We will give some time to open it. So, here we have the code. First of all, we have imported some of the libraries like matplotlib, sklearn, so that we can compute the accuracy score, confusion matrix. After that, we have changed our directory as I've used Jupyter Notebook. So I first changed my directory to the folder which contains my this CSV file diabetes2.csv. After that, in dataset variable, with the help of pandas, I've loaded the dataset and displayed the dataset. As we can see that there are 768 rows and 9 columns. So it is intermediate data set. It's not a very big dataset. After that, we have displayed the information of the data set, like the data types of each of the columns, like pregnancy has integer data type, glucose has integer, and so on. And BMI and diabetes prediction function has float data type. Then we have described the data set, like what is the count, mean, standard deviation, and minimum maximum values. Then we have checked if there is any missing values in the columns. It is we can observe that there are no null values, so we can go further. Then we have grouped our data set with as by means of the outcome that it is diabetes is predicted or not. It's actually binary classification model, so one means predicted value is true, zero means diabetes is not there. So this is the graphical representation of the diabetic function data set. Then I have used pair plot from the Seaborn library to display the relationship between each columns. We can see that diagonal relationship is one, as it is the relationship between each and every column with itself, like pregnancy with pregnancy, glucose with glucose. So definitely relation will be one. Others are scatter plots. Then after that, as my friend has told in the PPT, we will be removing the invalid values, like blood pressure cannot be zero. So we will be removing the rows. It is also possible to fill the invalid rows with the average of the columns, but we have preferred to go by removing it to get a better accuracy. Glucose, BMI, and insulin. These have 5, 11, and 374 invalid values, and we have removed these respectively. This is the modified dataset after removing the invalid values, which contains 392 rows and 9 columns. After that, I have imported the classification models like K-neighbors and support vector machine, then logistic regression, decision tree, random forest, and Gaussian NB. I've appended each of these models along with their names in a list called models. Then after that, I've divided the dataset into X and Y. Y contains the outcome, X contains all the values like insulin, BMI, which are responsible for detecting the output. Then after that, I have trained and tested the dataset. Like I've divided my dataset into X train, X test, Y train, Y test. X train and X Y train will be responsible for training the dataset, and X test and Y test will be responsible for testing the dataset and getting the accuracy. The test size, that is the testing part of the dataset, will be 30%. 30% of the dataset we will be using for testing the dataset, and rest 70% for training our model. So in this for loop, as we can see that I am fitting each and every model from the model list and appending the accuracy score of each of this model in the scores list. And we can see that it after displaying the individual accuracies of each of the models, as KNN is 70%, logistic regression is 76%, decision tree is 75, random forest 76, and Gaussian NB is 77%. So after that, we have, for a better visualization, we have plotted the accuracies with the help of a bar chart. So we can see that logistic regression and Gaussian NB has the highest accuracy scores. Further, we will apply cross validation to again get better accuracies. Cross validation is actually taking different parts of the data set for training and testing. So same thing we have done, and we have k-fold means the number of splits we are making in the data set, like n splits equal to 10 we have taken. Then after that we have applied cross validation and again got the accuracy scores which are better than the previous one, but the conclusion is same, that logistic regression and Gaussian NB has the highest accuracy scores. So we will be applying logistic regression first to our training model, and then we will check after using cross validation the accuracy score, standard, mean, and individual accuracies. Like These are the individual accuracies after applying cross validation to each part of the dataset. Then we will be predicting the outcome for the whole dataset. Like in the previous part, we have done prediction only for the testing dataset. Now we have predicted for the whole dataset. Then we will be applying the cross validation score for the whole dataset, and then we we can see that we are getting an accuracy score of 77% for the whole data set. Then we have plotted the original data set with the help of a scatter plot. Cluster 1 is plotted with the color red color. It means that the prediction is 0. So diabetes is not predicted. And 1 means it is predicted. It is represented by cluster 2, which is blue color, which is for the original data set. Same red and blue color for cluster 1 and cluster 2 are also used in the predicted models accuracy. So we can see this is the, here is actually we can see there is some difference, like from 60 to 120 we can see in the original data set that there are blue colors in the original data set means that the prediction is actually 1. And in the second one we can see that from 60 to 120 it's actually there is no predicted values the matching, so it is red. So that is that depicting that our accuracy score is 77 or 78%, which is a decent score. We could have like bettered it. Then after that we have applied the Gaussian NB. In Gaussian NB also we have applied cross validation and got the accuracy score, mean, standard deviation, individual accuracy of each part after applying cross validation. We can see that the highest one is 82%. Then after that we have plotted the data set, original data set, same cluster 1 with the help of red color in the original data set, which means that the predicted value is not matching, like, and in cluster 2 means predicted value is 1, that is blue color. Same for the predicted data set, like cluster 1 red color means predicted value is 0, and cluster 2 blue color which means predicted value is 1. So here we can see that Gaussian NV is giving slight better result than the logistic regression. So this is our project. My friend will be concluding the project and okay, handing over to my teammate.
Okay, thank you, Nibran, for that detailed explanation. Now I'll be summing up our project with some few result comparisons. So, as my teammate said, the logistic regression had an accuracy score of 77.55%, and the Gaussian NB had a score of 77.11%. So, it can be concluded from the above results that logical regression, applying logical regression to the model gives a bit more accuracy. So, now some learnings we had from this particular project. We were able to learn some of the basic concepts of machine learning. We learned about algorithms like logistic regression and naive Bayes classifier. We learned the concept of cross validation. We also learned how to represent data graphically using Matplotlib. Thank you so much for your time.
So our team will be signing off. Thank you.